Good evening. Now we will see truss problems. So we have this calculate forces in the members of truss due to external load considering member BD as redundant. So they have given which member you have to consider as redundant. So we have step 1, static indeterminacy. Static indeterminacy. So we have ds equal to R minus equilibrium equations. So we have this as one reaction, then we have 1, 2, then we have this as 3 minus 3 equal to 0. Then we have dsi m minus 2j minus 3 minus 2 into 4 minus 3 and we have 1. So truss is internally redundant to degree 1. So we have dse plus dsi equal to 0 plus 1 is equal to 1. So truss is internally indeterminate to degree 1. Step 2 we have selection of redundant. But here redundant is already given. So we need not require to select it. And therefore we can write consider BD as redundant. Consider BD as redundant. Now we have to find out forces due to external loads. So we have to, now we have P forces. So we have step 3. We have step 3, P forces. And while finding P forces, remove redundant. Remove redundant. And therefore we have removed redundant over here. We have this as A, B, C and D. Angle we have given that is 45 degrees. Now we can see which are zero force member. So 100 kilonewton member BC as collinear. So we have force in member BA. So that force in member BA we have 0. Or if we will consider joint B, then what we will get? We have this as 100 kilonewton. So to balance this 100, we have in this 100 kilonewton. And automatically summation Fy0, this becomes 0. So we have now this will be 100 kilonewton. And that will be tensile. Now we will consider joint C. So what we have at joint C? So we are with joint C. 100 kilonewton. Then we have this downward 100 kilonewton. And we have this member. So now this angle is 45 degrees because we have both L and L. And in this letters we will say we have force in CA. Now we will apply summation Fy equal to 0 and then we will get FCA sine 45 minus 100 and that is equal to 0 and we will get FCA is equal to 141.42 kilonewton. Value is plus, so it is tensile. So we have force in this is tensile and value we have 141.42 kilonewtons. Now let us we have force in this member we have FCD and then we will apply summation Fx equal to 0. So we have minus FCD. Then due to FCA again we have minus. So I will directly put FCA 141.42. So we will not write here minus FCA cos 45 and minus 100 and that is equal to 0. And from this we will get value of FCD equal to minus 200 kilonewton and that shows compression. So we have FCD minus 200, or I can say this as 200 kilonewton. Now if I will come at joint D, then we have these two are collinear. Automatically force in this member is 0. So we have these are the P forces which are expected in this question. Now we will switch over to the second question. So we have over here calculate forces in the member of the truss due to unit load considering BD as redundant for the truss as shown. So now we have to apply unit force in BD. And then you can see this, I have already considered this. This is our truss. While applying unit load, we have to remove all external loads and we have to apply then unit load in BD. So now we have these as A, B, C and D. Now we will go one by one. We have this angle as 45 degree. So I will consider joint B. And then we will see what values we will get. So joint B, if I will consider, so we are in this fashion. So this is 1. And then we have this member as FBA and we have this member of FBC. Then we will apply summation Fx equal to 0 and we will get it as minus FBA minus 1 cos 45 and that is equal to 0 and therefore we will get FBA minus 0.707. So I will mention it as 0.71, no unit. That is most important. Minus sign is compression. Then I will apply summation Fy equal to 0. So we have minus FBC. Then we have minus 1 sine 45 and that is equal to 0. And we have FBC also minus 0.71 and that shows compression. So we have FBA compression 0.71. We have FBC also compression 0.71. Now if we will come to C, then we are in the same fashion. So this now this become 0.71. So automatically this goes to 1. Means if we will consider joint C, then we are with joint C and we have to find out this value. This is given 0.71 and let we have this will be FCA. And this angle is 45 and then we will write summation Fy equal to 0. So we have FCA sine 45 minus 0.71 is equal to 0 and we will get FCA that is 1. So FCA 1, so other values we are in the same fashion. So we have again this value then becomes 0.71. Then this value also becomes 0.71. So we have these are the values which are due to unit forces. So this is about your question which is related with this question and then now we will see next question. So we are with this question now. So we have calculate forces in the members of truss due to external load considering member AC as redundant. So now we have AC redundant. So steps we are in the same way. Step 1, static indeterminacy. So we have static indeterminacy. Now in your truss, which is in this way. So we have this cantilever. Now this we have roller and this. So better in case of cantilever start to solve from right. So in this you will not be confused because if you will go to DSE, then you will be confused. How many we have to consider over here? So we have to consider 1 here or we have to consider 2 here. And then that will be problematic. So DSE, if we will consider from this, then we have 4 minus 3, 1. So DSE 1. But in cantilever, you need not require to consider this. You have to start to solve from D point. Now you will go DSI, and then mainly we are interested with DSI M minus 2J minus 3. Then we have M, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 minus, then we have 2 into 5 joint minus 3, and this will be 1. And we have internally redundant to degree 1, externally redundant to degree 1. But we are interested with internal redundancy AC. And therefore we will not go to this, we will remove AC. So what will be second step? So in examination, you can keep this DSC 4 minus 3 1, DSI 1, and then you can write DS equal to 1 plus 1, 2. But step 2, I will say, that is selection of redundant. Now we are interested with AC, so we will selection of redundant, and we will mention here member AC is redundant, and this is given. And we are interested with this only. We are not interested with the reaction. And then we have this is 100 kilonewton. So we have removed AC, A, B, C, D. So we have removed AC, and then we will find forces in the member. Now we have this angle as 53.13. So same over here 53.13. And then we will consider A, B, C, D. Sorry, A, B, this is E, and this is G. Now we will consider joint D. We have this as 100 kilonewton, 53.13. This is FDC, and this is FDE. Then we have summation Fy equal to 0. So we have FDC sine 53.13 minus 100 equal to 0, and therefore we have FDC equal to 125 kilonewton, which is tensile. So we have force in this member, that is 125 kilonewton tensile. Then we have summation Fx equal to 0. So we have minus FDC cos 53.13 minus FDE, and that is equal to 0. And we have FDE equal to 75 kilonewtons. So now we can put these values in the truss. So we have this as tensile 125 kilonewtons. And then we have DE, which is 75 kilonewtons. Now, if we will go to joint C, if we will see carefully, then we have joint C will be in this fashion. So this is 125. Now I will not go with the solving of this joint. So this is 53.13. Now its cos component will balance this, and this sine component will balance this. And the sine component we have 100 kilonewton. If you cannot understand, you can solve this joint, right summation Fx 0, right summation Fy 0. So this vertical 100, horizontal we have 75 kilonewtons. And then if we will come to joint E, now at joint E, you can see we have this as 100 kilonewton vertical. So automatically we should have force in this member 125 kilonewton. Now this you should be in position to understand this. If I will consider joint E, so we have this will be my joint E and this force. So we have this as 100 kilonewton. We have this as 75 kilonewtons. We have to find out in FEB. and this is FEA. So if you apply summation Fy0, then we have FEB sine 53.13 minus 100 equal to 0. You can see we have same equation over there. And therefore FEB we have 125 kilonewton. Now we have 75. So this becomes 150 kilonewtons. Now you can solve this. If you will write it, minus FEA minus FEB cos 53.13 minus 75 equal to 0, and we will get FEA minus 150 kilonewton, and minus means we have compression. So we have this value 150 kilonewtons. Then we have next problem. We have to find out that is truss due to unit load. Now we have to go. So in AC we have to apply unit value. So we have this as AC, then this is D and this is E. Now we know at joint D we do not have any other force. We have two members. So we will get both members as 0. Now we have this angle as 53.13. As we have internal, so my all reaction should be 0. So this is 0, this is 0. So we have this 0, we have vertical 0. Now I will consider joint C. So what I will get joint C, we are in this fashion. So this value we have 1. This angle we have 53.13. Member force we have FCA. Then in this we have FC. Then we will apply summation Fx equal to 0 minus FCA minus 1 cos 53.13 equal to 0. And we will get therefore FCA equal to minus 0.6. So you can check it. That is cos 53.13. So 0.6, because we have 4/3. So this angle we can have 4/3. So shift tan inverse 4/3, we have 53.13. So we have this will be minus 0.6. Then we will apply summation Fy0. So we have minus FCE minus 1 sine 53.13 equal to 0, and we will get FCE that is equal to minus 0.8, and then you just show these values in this. So we have this will be vertical, we have FCE, we have 0.8, then we have FCA, this is 0.6. And if we will go to joint A, then what we will get at joint A? So we are with joint A now. Now these reactions are 0 and we have this as 1. And therefore we will get same. This we will get as 0.8 and this we will get as 0.6. So we have this value we have 0.6 and this value we have 0.8. And automatically we will get value in this diagonal. So that is going to be 1. So likewise, we have to solve the problems when we will talk about these members. So now we can have this one of the problem, calculate the forces in all members of the truss if the top chord members only have a rise of temperature. Now if we will go to this, then we have DSI that is equal to M minus 2J minus 3. And now if we have M we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have M9 minus 2 into J, 1, 2, 3, 4, 5, 6, minus 3, 0. So it is internally redundant. Sorry, internally determinate. And as it is internally determinate, in determinate trusses, forces will not be developed. Forces will not be developed will not be developed due to lack of heat or temperature change. Lack of heat or temperature change. Therefore, forces in all members are zero. Forces in all members therefore become zero. So likewise, we have these truss problems. So in the next video, we will see another remaining problems of the truss. So thank you.